Let us now do some more questions on recursion. Please take a closer look at this recursive function and try to guess the output of this function or return value of this function for input n equal to 16. This function returns a value 4 for n equal to 16. Let's see how do we get this value 4. When you call for 16, it checks for this if condition, begins the execution from here. N is not 1, so it does not go inside this if condition, it goes into the else part. So what it does, it calls for 1 plus fun8. This is what it's going to return, but it needs to compute fun8. So when you call for fun8, it's a function call and it's going to begin the execution from here again, and it's not going to fall into the if condition because it's not 1, so it's going to call 1 plus fun4, and fun4 is going to call 1 plus fun2, and then fun2 is going to call 1 plus fun1. When this calls happens, all these functions are there in the function call stack waiting for their child calls to finish, right? So your function call stack now contains 16, 8, 4, 2 and 1. And now when this calls happen, this call goes into the base case, right? And what it returns? It returns 0 to its parent. So its parent gets the value 0. Now what parent is going to do? Parent is going to do 1 plus fun1, right? And it has returned value 0. So it's going to return 1 plus 0, right? So this fun2 is going to return 1 plus 0, which is 1 to its parent. And now what its parent is going to do? Its parent is going to do 1 plus returned value by this function call, right? 1 plus fun2. That's what fun4 is going to do. So fun4 is going to return 1 plus 1, 2 to its parent. Now what its parent is going to do? Its parent is going to do 1 plus this value, 1 plus 2 is 3. So its parent, which is fun8, is going to return 3. Now fun8's parent is fun16, and fun16 is going to do 1 plus 3. So it's going to return 4 to its parent. So that's how we get the value 4. So we have seen the output for n equal to 16. Now please pause this video and try to guess what does this function do in general where n is greater than or equal to 1. If we always pass a number which is greater than or equal to 1, what does this function return mathematically? Let us first understand the working of this function when n is a power of 2. What will happen? You will call for fun n, it will call for fun 1 plus fun n by 2, then 1 plus fun n by 4 and so on, and ultimately it will call for 1 plus fun 1. Let's now see different values. Fun1 is 0, base case. Fun2 is 1 plus fun1, which is 1 plus 0, which is 1. Fun4 is 2. Fun8 is 3. Fun16 is 4. Fun32 will be 4 plus 1, 5. So when we are multiplying our input by 2, our result is being incremented by 1. And this is the nature of log. So this function returns log of n when log base 2n when n is a power of 2, right? When n is a power of 2, it returns log 2 base n. You can notice that fun1 is 0, right? Log 1 is 0, log 2 is 1 base 2, right? Log 4 base 2 is 2, log 8 base 2 is 3, and log 16 base 2 is 4. So this is how this function works, and that's the general rule that we must know when we do programming, that when you divide a number by 2, right, and if you recursively do it, number of times that you do it until it becomes 1 is log, right? It's always log. So this function returns log of n when n is a power of 2, right? What about the cases when n is not a power of 2? Let's see what will happen when you call it for fun17. So fun17 will be doing 1 plus fun8 only, right? Because it's an integer division. So it's going to avoid the remainder, right? Whatever remainder you get, and it's going to do simple 1 plus fun8. In fact, if you call it for 1 plus fun18, then it's going to call 1 plus fun9, and then it's going to call 1 plus fun9 is going to call 1 plus fun4. And here you again remove the remainder, right? So for 18 also, you are going to get the same answer as 16, right? You will get the answer same as 16. You will get 1 plus 3, right? 1 plus 3 you will get. And 17 also, you got the same answer, which was 1 plus 3 because it was 1 plus fun8. Now what happens for 19? you get 1 plus 9 again, and you again get the same answer. For 20, you will get 1 plus, let's see 20, you will get 1 plus fun 10, and fun 10 is going to call 1 plus fun 5, and then it's going to call 1 plus 1 plus 1 plus fun 2. Right, and this is going to return again the same value which was same as fun 19. So the point is, if you keep on increasing n until next power, it will give you log of floor of n, right? For 17 also it's going to get you what 16 returns, for 18, 19, 20, it's going to give you the same value until fun 31. And after fun 31, at fun 32, it will give you one more value, which is 5. You may notice that for 31 also, we are going to get the answer as 4. For 31, you will call 1 plus fun 15, fun 15 will call 1 plus fun 7, then it will call for 1 plus fun 3, then it will call for 1 plus fun 1, right? 3 divided by 2, when you do integer division, you get 1. This will return 0, right? And this will return 1 plus 0, 1. This will return 1 plus 1, 2 to its parent, and the parent will return 1 plus 2, 3 to its parent, and the parent call will return 1 plus 3, 4 to the parent. So for 31 you are getting 4. For fun 32 you will get 5, right? Because you will get straight away division by 2 everywhere. So this is the functionality of this function. It returns floor of log of base 2n. Now a quick question for you. If I do by 3, then what you will get? You will get log of floor of base 3. You need to change the base condition as well. The new base condition for 3 would be n is smaller than 3, right? When n is 1 or n is 2, right? For these numbers, you are going to return 0. Please take a closer look at this function and try to guess the output of this function for n equal to 7, and also try to guess what does this function do in general. I have written here some pseudo code, right, which is close to both C++ and Java. So in C++, you need to replace this print statement with cout, and if you program in Java, then you need to replace this print statement with system.out.print. Now you please pause this video and try to guess the output of it. The output of this program is 111. And how does this function execute? When you call for fun 7, it does not go into this condition, if condition. So it comes here, and when it comes here, it calls for 7 by 2, which is 3. And now fun 7 waits for fun 3 to finish, and once fun 3 is going to finish, then it's going to execute this line where it prints remainder with 2, which is 1. So when you call for fun 3 begins its execution here, does not go into the base case, calls for fun 1. Right? So when you call for fun 1 again begins its execution from this line. N is not 0, so it's going to come here and it's going to call itself with 0 parameter. When you call for 0, it falls into the base case, so it immediately returns. Now fun 1, which was waiting for fun 0 to finish here, gets the control, and fun 1 is going to execute this line, and this line is remainder with 2. So when you do 1 remainder 2, you get the output as 1. For every odd number, when you do a remainder with 2, you will get the output as 1. For even numbers, you will get the remainder as 0. So fun 1 now prints 1, fun 1 leaves the execution, fun 3 gets the control, fun 3 was waiting for fun 1 to finish, so fun 3 is going to now execute this line, 3 remainder 2, 1, it's going to print 1, so fun 3 has finished its execution, this was the last line for fun 3, fun 7 is going to get the control, and fun 7 is now going to print 7 remainder 2, which is 1. So first you see this one on the output, then this one, so your output is 111. Now please pause this video and try to think what does this function do in general for a number n which is greater than 0, right? Your number input is greater than 0. What does this function print for this number? This function actually prints binary equivalent of a number n where n is greater than 0. Let's see one more example for n equal to 13. When you call for 13, it calls for 6, then it calls for 3, calls for 1, and then calls for 0. So when you call for 0, you fall into the base case. Then fun 1 gets the control, it prints 1 modulo 2, 1, right? Then fun 3 gets the control, it also prints 1. Fun 6 gets the control, it prints 0. Because 6, when you divide by 2, you get the remainder is 0. 13, remainder is 1. and you get the output as 1, 1, 0, 1. So this is what is your printed in on your screen. This process, if you see, is same as decimal to binary conversion. In decimal to binary conversion, what we do is we keep dividing the number by 2 and we keep storing the remainders that we get. So we divide the number by 13 and we store the remainder as 1. Then we divide the number by 6 and we store the remainder as 0. Then we divide the number by 3 and store the remainder as 1. Then divide the number by 1 and store the remainder as 1. Now, after doing all this, we print these remainders in the reverse order. That's what we do when we write code for decimal to binary conversion. That's what this recursive function is also doing. So this recursive function prints binary equivalent of a decimal number n, where n is greater than 0.